Yes, sir.
So, today is a demo class on embedded system. Okay, so
Yeah,
basically this
sir.
is our first class. Last time we discussed about some important topics, na? So what are those
Yeah, yes.
topics we discussed that time?
Memory management. We discussed about memory management, variables, and some data types.
Okay, so basically that class was related to the C programming, na? So uh,
Yeah, yes, sir.
this is related to the embedded system. So here we will discuss all the important things related to the embedded systems architecture, okay, and some other
Hmm.
peripherals of microcontroller. So
Yeah.
let's see.
Yeah, okay, sir.
So first, what is an embedded system? So you understand, na? You all know, you already know that what is an embedded system. It's combination of hardware and software.
Yeah.
Yes, yeah. So it's a combination of hardware and software and real-time control systems. Okay. So generally,
Hmm.
that is why now we are using RTOS or free RTOS we use for the real-time controlling purpose. Got it?
Hmm.
An embedded system is designed for doing the specific task. It is not used for the general purpose task. Huh? That
Hmm.
general purpose task, our laptop can do that. Got
Yeah.
it? So basically, you will see some applications related to the embedded systems. Okay. So what are those applications or examples? Like if we talk about consumer electronics, so so some examples under the consumer electronics like washing machine, EV charging systems, and a smartwatch. Got it, na?
Hmm. Got it, sir.
And automotive system like a car ECU, electronic control unit. No?
Hmm.
Inside the cars, basically there are multiple ECUs. So all the ECUs are basically nothing, just the microcontrollers. Got it?
Hmm.
So
Got it, sir.
we flash the code inside those ECUs, and the ECUs will control the peripherals of the car. Got it?
Hmm.
In if we talk about in medical devices, there are multiple medical devices like neck sensors, uh, uh, any kind of medical devices you can create with the help of microcontrollers. Got it?
Yes, sir.
The devices which are used for measuring the blood pressures or heartbeats. Okay, so all the
Hmm.
devices consist of the microcontrollers basically.
Hmm.
Nowadays we are seeing, like we see smart traffic lights. So these traffic lights are basically nothing. These are the part of embedded system as well.
Hmm.
Got it?
Got it, sir.
So these are the fields basically where embedded system can be used, or a part of it aerospace and
Yeah,
some
defense
defense
systems.
systems and on some other examples. Tell me.
Uh, yeah, aerospace and defense systems and other things which you have mentioned already.
So electronic consumer lifts we can consider lifts basically, na? Accelerators and
Yeah.
lifts. Okay, and metro gates basically these are automated with the help of microcontrollers. Got it?
Hmm.
So these all are the examples of of embedded systems. So
Hmm.
embedded system is consisting of hardware, software.
The software.
Yes. So basically, hardware means microcontroller is a hardware device. Got it?
Yeah.
So if you want to control anything, then you have to flash some software inside it. Got it?
Yeah.
So then it will work.
Hmm.
Yes. So let's move forward. So this is the same thing. Embedded system can be defined as data processing tool designed for specialized functions. It is basically combination of hardware and software designed to perform a specific task or functions. Got it? So let's see how the flow works. Okay, so let's consider sensors, basically temperature sensor. Okay, got it.
Mm.
And temperature
Got it.
sensors basically connected with a processor. Okay, by a ADC. Okay, so there are two things in
Mm.
microcontroller, analog to digital conversion, digital to analog
And digital
conversion.
to analog conversion.
Yeah, so sensors basically are reading some analog signals and sending it to the ADC, and ADC is converting that analog signals into the digital signal, and digital
The
signal,
digital signal will be sent into the processor.
yeah, digital signal will be sent to the processor. So processor will understand the digital signal and will execute the instructions of the firmware that you have already put inside the processor. Got it?
Mm. Yes,
and
sir.
and it will give you some output, so the output will definitely be digital. Got it?
Mm.
So but in the real term, real world, or for controlling the peripherals of microcontrollers or other peripherals, you need analog signals. Got it? So
Mm.
that is why we are using DAC. So this
Mm.
DAC is converting analog signals to digital signals to analog signals. Okay, so actuator may be your fan, your LED lights,
Yeah.
anything it may be, na? Output
Yeah.
device. Okay, so you understood one thing, like this is the part of your microcontroller. Got it?
Mm. Yeah.
What is the part of your microcontrollers? I draw it now. So this is part of your
Microcontroller.
microcontroller. Got it?
Sir, I couldn't understand one thing. Why you have mentioned processor two times, sir?
I will tell you that.
Yeah.
So first, this is the part of microcontroller. So I told you the internal working process of microcontroller.
Mm.
Understood?
Understood, sir.
So this is your temperature sensor. Here is analog signal. Okay. And this analog signal will converting into the digital one, and digital signal will go into the processor, and processor will understand the sensor's value. Okay, so basically a processor will not directly connected to the, 1 minute. Hello.
Yeah, yes, sir.
Okay, so you understood the process or
Mm.
internal workflow. So basically, your processor will understand the sensor's value. Okay, and will give some output, and which so this actuator will be controlled on the basis of temperature sensor's value. Okay,
Mm.
but who will control the actuator? The processor output will control the processor. Got it?
Mm.
So signal
Okay, sir.
conversion is important.
Mm.
So why I have written processor two times? So this is, you can consider this one is different microcontroller. Suppose suppose this is your STM32 and this is your ESP32 microcontroller. Okay, and both microcontrollers are communicating with each other. Understood?
Mm. Yeah.
So there would be some bidirectional communication between both microcontrollers or both microprocessors.
Yeah.
Okay, so
Yeah.
and there would be some communication protocols like UART.
Mm.
So on the UART, both processor will communicate with each other. Understood?
Mm.
So basically, microcontroller has nothing. It has a processor. It processor is a brain of microcontroller. Okay,
Mm.
it do all the all the execution of instructions.
Mm.
Yes, if the processor will not be inside the microcontroller, your microcontroller will not work.
Yeah.
So this is something related to the internal workflow. So should we move forward now?
Yeah. Yes.
Yes. So we will understand the main blocks of microcontroller. So first is CPU, Central Processing Unit. That is processor basically. Okay, it's a brain of the microcontroller. Understood?
Mm. Yeah. Yes.
And it execute the instructions. mm,
Yes, sir.
and it performs arithmetic and logical operations as
Or
well.
logical operation.
Yes. So I told you, na, CPU is important.
Mm.
So let's see some examples. ARM Cortex M4 series, 8051 microcontroller, AVR and PIC. Okay,
Mm.
got it, na? So generally, in colleges, we cover 8051 microcontroller, which is
Yes, sir.
not too much used in industries. Okay,
Yeah.
but used in some automotive industries. Generally, we focus on ARM Cortex M4 series microcontroller.
Mm.
Okay, like STM32 and ESP32. ESP32 has a different processor. But
Yeah.
yes, so ARM Cortex M series M, and this is the processor. Got it?
Yeah. Yes.
So this is it's the processor, and
Mm.
ARM is a company basically, na,
Company. Yeah.
which made this processor basically. Got it?
Mm.
Yes. Second block of microcontroller, that is the memory. Okay, so memory has different segments. Like it has a flash memory. Okay, so
Yeah.
flash memory, you understand, na? There is a permanent memory and there is a temporary
Mm.
memory. So flash memory is a permanent memory. Okay, so it stores
Yeah.
program and code permanently. Got it?
Yeah.
It's non-volatile memory. The flash memory is also called as non-volatile memory. Got it?
Yeah.
Yes. And some other memories like RAM and EEPROM. Okay. So
Yeah.
RAM basically RAM, a temporary data storage variable stored during executions. Okay. So I told
Mm.
you, na, ki like you are storing your code here in flash memory. Okay.
Yeah. So during runtime, the program will be stored in RAM.
Yes. So normally you will flash your code or store your program or code in flash memory. Okay. So
Mm.
that the things would be in permanent way. Okay.
Mm.
Otherwise, what will happen? Like suppose one time you have flashed your microcontroller, and after some time it will erased, the data or code will be erased completely. Na? Again you
Yeah.
have to flash. Again you have to flash. So flashing, like it is very difficult task. It is time consuming. Na? You cannot flash
Yeah.
everything. Suppose you have built a product. Okay, like suppose you have built EV charging system. Okay, and now you have written the code, you have flashed it in Bangalore, or you have sent that product into the production, or you have sent that to the customer side. Okay. And
Mm.
suppose if a code is stored in a non-permanent memory, it will erase every time na? After some time,
Yeah.
every time.
Yeah.
So that product will not go into the production, that product will not go to the customer site as well. Okay. So that is why na, we need to store code in the permanent memory. Hmm? So
Yeah.
runtime execution will happen in RAM area. Okay.
Yeah. Got it.
RAM is a temporary memory, hmm, or it is
Mm.
also called volatile memory. Hmm.
Mm.
So double E ROM, it is also part of permanent memory. Okay, but it doesn't store the complete program or complete code. Okay, because its size is small. Okay,
Oh,
so it
so.
stores small data permanently, like configuration values, configuration settings. Got it?
Mm.
Configurations kind of things it will store double EEPROM.
Yeah.
This thing you understood well.
Yeah, yes, sir. And EEPROM is kind of erasable memory, right?
Yes,
Yeah.
but the data will not erase automatically na, like RAM.
Yeah.
Inside the RAM, the data will not exist like to the longer time. It will exist till the execution is happening. Otherwise there will be no data in the RAM. Understood?
Mm. Yeah, understood, sir.
Yes. So here I have written a flow basically. Okay, so that embedded system is a small and low power and low cost computer designed to be used as a part of large machine or system. Therefore, it works in the same way as ordinary computer does. So here we have defined some steps. Okay, so this basically in previously we saw a flow. Okay, understood na? So what is happening, like it reads some data from sensor and
Sense.
converting data, okay, into the readable format so that
Yeah.
processor could understand, and processor execute some instruction and convert input into the useful outputs. Got it?
Got it, sir.
And then output basically the processor will convert the output into the actuator readable format. Okay, and actuator read the output and perform the desired actions. Okay,
Mm.
so here we see the difference between the microcontroller and microprocessor basically in the pictorial format. So you understand like what is the processor, what is the microcontroller, CPU. Hmm?
Yeah, yes.
So basically there are some peripherals in the processor which are externally connected with the CPU. Got it?
Got it, sir.
Like timer, input, output, serial interface, RAM, ROM, all are externally connected with CPU. But in microcontroller, all the things, all the peripherals are inside on the same chip, okay, or inside the processor as well. Okay, so basically the all the things are on the same chip. Okay, that small chip.
Yeah.
So double EEPROM, timers, RAM, CPU, input and output pins, ROM interface, and with all these peripherals, your CPU will communicate.
Mm.
Got it?
Got it, sir.
Hmm. So here we see the core components of embedded system. Like what are the core components? Hardware basically microcontroller, sensors, actuators, and communication interfaces. And software basically embedded C programming. Softwares are written in C programming, na? Embedded C.
Yeah.
So what is the difference between embedded C and normal C?
There are specific functions for embedded C, sir. In
Mm-hmm.
normal in a C programming, we don't have that much specific function. For example, uh, like mentioning the register and using this kind of register functions and all is there, right?
Yes, yes.
SFR kind of
So
functions.
in
Yeah.
normal C, we cannot directly control the hardware peripherals, no? But
Oh,
in
okay.
but in embedded C, some special functions are given. The syntax
Mm.
is almost same. Okay,
Yeah.
basically syntax wise is same, but the functions wise different. Okay,
Yeah.
so in embedded C, the functions will which will control the hardware or peripherals of the microcontrollers
Mm.
and drivers. Understand the drivers. What is the drivers basically?
Uh,
See, suppose there are some peripherals like CAN, UART, SPI,
mm.
I2C. So all the
Mm.
peripherals will work. There is a specific driver for all these peripherals. Okay.
Yeah.
So there are one is basically this is a driver layer. Okay. Suppose this is your firmware, like this is your microcontroller, and this is your driver layer, and this is your application layer. Okay.
Mm.
So without a driver layer, your peripherals will not work. Okay, or application layer will not work. Got it?
Got it, sir.
So drivers basically are used to run the particular peripherals related application logics. Or
Yeah.
yes. So drivers can be generated automatically, or it can be written by a programmer as well. Got it?
Actually, we use some kind of we actually install some drivers to make it communicate with the
Peripher
microcontroller, right?
yes,
So,
yes, a
yeah.
microcontroller. Peripherals, not
Yeah,
microcontroller.
peripherals. Yeah,
So
peripherals.
processor and peripherals will communicate when there is a driver will be like okay, there will be driver.
Yeah.
Without driver, they will not communicate. Okay,
Hmm.
your application logics will not work, you know.
Yeah, yes, sir. Because some linkers they don't have that much adaptability. So to adapt the peripheral with the our system which we are using, like laptop or monitors,
Mm-hmm.
we do install some drivers
Yes.
for
So,
the
so
communication
so that
purpose.
is why the same way we do in a microcontroller as well. Okay, like
Yeah,
ABC STM32, okay, there is a cube ID.
yeah,
So basically, there are some
yeah.
IDs which are used for writing the programs for the particular
Mm,
microcontrollers. Got it. So there are two things in STM. One is given like you can directly do write the application logic,
access the yeah
or
application
or
logic, and
or
the other one is like actually using the direct pinouts of the STM32.
no, no. So basically, one is thing like it will generate the drivers automatically. Other, it will say you want to
Yeah.
write everything from by your own self. Okay.
Mm,
So there are two things. Once you will initialize all the peripherals of microcontrollers, like suppose you are going to work with the UART, so you will initialize the pins related to the UART and you will
mm,
generate the code, and then you
mm,
will click on the generation button. Okay, that will generate the code as well as that will generate the drivers related to the UART. Okay,
mm,
that will not generate the driver related to the CAN protocol, na? Because we are working on UART only, na? Okay,
mm.
so it will give you the UART driver only.
Yeah.
When you will work on a CAN, then you have to initialize
Initialize
the
scan protocol.
CAN
Yeah.
protocol. You have to configure the pins related to the CAN protocol. Okay,
Mm,
and you will generate the code, and then STMQID will will give you the drivers related to the CAN protocol. Okay,
mm.
so firmware, like what is a firmware? So in basically that software is called firmware. Okay,
Familiar.
and RTOS is very important because multiple tasks. Okay, we work together. uh, Understood na,
Yeah,
friatos.
to schedule the multiple tasks on
Yes,
in a single time,
in a
we need
single
our
time.
boss
So you can manage the multiple tasks with the help of friatos
simultaneously. Yeah,
simultaneously in the real time. Okay.
yeah,
So timing is very important in the embedded system. So that is why, like,
mm,
and it is very demandable skills. Every company asks for the friatos. You should know
mm,
friatos.
yes,
See, you should know the embedded C. You should know the driver development. Okay. Or
yeah,
you should know the firmware logic writings, and you should know FreeRTOS. These
yeah,
all four things you should know when you want to get job in a embedded system.
yes,
So you have to be master in embedded C. You have to be master
mm,
in drivers as well. You have to be
mm,
masters in firmware writings and FreeRTOS as well. These are the highly demandable skills.
yeah.
Okay. So microcontrol, these are some microcontroller peripherals like CPU, okay, and GPIO port, ADCs,
Mm,
UART, timers, PWM, and flash
mm,
memory and RAM memories. Okay, some of
mm,
those internal blocks we have discussed. Okay, so let's see the block diagram of microcontrollers. So basically, when you will see the microcontrollers, let's say microcontroller has some internal blocks like this: RAM, ROM, CPU, timers. Okay, all these are inside the microcontroller on the same chip. Understood? This is very simple to understand.
yes, sir.
Hmm. So, what you are understanding from this picture?
So together a CPU and a memory, it is a microcontroller, and via the bus there are so many peripherals are connected to it.
So basically, CPU wants to communicate with the peripherals.
Communicate
Okay. So how CPU will communicate with all these peripherals? With the help of
through
bus.
a bus.
Bus.
Yeah.
The same way, uh, a memory will communicate with CPU. How? With the help of
Mm,
bus. Okay. So the
mm,
bus is very important part or important segment in the microcontroller. Without bus, any kind of peripheral will not communicate with each other. So this is also
mm,
bus. Okay, this is also bus. Okay.
mm.
So what is the purpose of bus? So
It,
working of bus basically to take and to export data from processor to peripherals or from peripherals to processor. Okay,
yeah.
or from memory to processor or processor to memory. Okay.
Yes, sir.
So suppose let's take an example of ADC. So you here the temperature sensor you have connected. Okay, and temperature sensor you will use the analog input. Okay, understood na?
Mm,
So here you will read the temperature value, and that temperature value will store here na memory.
yeah.
Okay, so this way the data will store inside the memory. Okay, and
Yes, sir.
CPU will take data from memory through a bus. Got it?
Yes, sir.
Similarly, all the peripherals, CPU and memories will work or will connect like this. So third peripheral is a GPIO, general purpose input output peripheral.
Oh, yeah.
Okay. So basically, like it is used to connect LEDs, switches, and relays and sensors. Pins can be act as input and output pins. So GPIO
Yeah.
pins can be used as input and output pins basically. Na? So there are
Yeah.
some modes you have to configure GPIO pins, either input or output. It
Hmm.
completely depends on your applications, what you want to do. Okay. Suppose you want to blink the LED, then
Hmm.
GPIO pin will be configured as output pin.
Output. Yeah.
Suppose you want to control the switches, so the GPIO pin will be configured as output. Relays, okay. But in case of sensors, GPIO pin
Hmm.
has to be configured into the,
Configured as input.
yes,
Yeah.
understood.
Yeah. Yes.
So there are two states of GPIO pin. Basically, you can say there are three states of GPIO pin. One is input, basically low and high mode. Got it, na?
Hmm. Yeah. Got it,
And,
sir.
and high G mode, high G state, high G state, low
High.
state, high state, and high G state. There are
Hmm.
three states of pin. So high G state is important. Basically, this state is called as floating state. Okay.
Sir, actually, did you change the uh, slide or what?
No, no, I didn't change the slide. I'm just telling you
Okay.
orally. Okay. So high G
Yeah.
here we are talking about the input and output. Okay. So this is another
Hmm.
mode basically. But we talk about the states. These are the modes. These are not
Okay.
states. Okay. So when we talk about states, so 0 1 and
Yeah.
high G, like it is neither 0 or nor 1. So this is called floating.
Hmm.
Okay. And this
Yes.
floating is not acceptable because it is a danger, it is dangerous, it is a danger
Hmm.
state. Okay. So so when we talk about high and low state, so in case of LED, so there would be some you will configure GPIO pin as output. Okay, so that state will be high state. Okay, what is the meaning of high and low state?
Uh, High and low state means on and off.
Yes, means you will get some voltage on the GPIO pin in case of output.
Yeah.
Okay, like 3.3 volt,
Yeah.
and a low state means 0 volt.
Yeah.
If I would say high, so LED will be on, means GPIO pin will have 3.3 volt. Okay,
Hmm.
if I would say like LED is off, so what is the pin state? 0 volt on the pin,
Zero. Zero.
and it is a low state. Okay,
Yeah.
got it, na? So this is
Yeah.
coming
Got
under
it.
this is coming under output mode. So we will talk about the clock system now. So general clock system generates timing signals. Okay, and 1 minute. I should erase all this. Yes. So clock systems are there are it's a very important part of microcontroller. Okay, so it generates timing signals, controls the execution speed. Okay, so there are two types of oscillators inside the microcontrollers basically, internal oscillator and external oscillators. Okay,
Yeah.
so the purpose of these oscillators basically to generate the clock signals. Got it? So
Yes, sir.
yes. So generally we use external clock oscillators because it gives you the stability. Got it? Internal clock oscillator provides some clock signals which is not like stable with temperature. Okay, as the temperature will increase, that clock signal will disturb. Okay.
Hmm.
Yes. So we will go into the detail as we move forward, but not in today's class. Okay, I'm giving you the
Okay, sir.
overview. I'm giving you complete overview.
Yeah. Okay.
Yes. So here the other peripheral is the timers. So why timer is used? Timer and counters are used to generate the delay and also PWM generation. Got it? So PWM
Got it.
is very important in embedded system.
Embedded system.
Yeah. So and delay is also important. Okay.
Yeah.
So what is a PWM? It's a
Pulse width modulation.
yes, yes. So what is the purpose of pulse width modulations?
uh, we use during the digital signals generation, yeah, and
No,
it helps.
mm-hmm, mm-hmm.
Actually, it helps to like modify the width of the pulses that is being generated. If we
Mm.
are going to modulate the signal, we need it gives a much more clarity signal actually.
So basically, see, it is not like basically we should talk in a more technical way. Like it is controlling the power delivery to the
Okay.
motor or any other peripherals. Okay.
Yeah.
So suppose PWM generally used for the power controllings. Okay. You can control the speed of motor with the help of PWM signal. So you have to
Oh, yeah.
control the signal, you have to control the PWM signal. So PWM signal will automatically control the power delivery to the motors, okay, and it will control the speed high and low.
Yeah.
Sometime so sometime you want more speed in the motor, and then you have to set the duty cycle accordingly, no? It works on the duty cycle.
Mm.
Okay, so go through in detail of PWM generation, what is the duty cycle? Okay.
Yeah. Okay, so,
In EV charging systems, the duty cycle, everything is based on the PWM. Without PWM, charger and car will not communicate, or charger will not
mm,
deliver, do any kind of delivery of power to the electric car.
mm,
So the person who knows the handling PWM signals or duty cycles can do much more things. Okay.
yes.
And applications, like what are the timers applications? Basically motor control, okay, and PWM for the converters, LED dimmings we can use.
Yes.
So there are some communication interfaces. What are the communication interfaces? Like UART, okay. So UART is basically a serial communication, and
Yeah.
yeah, so it is serial communication and used for debugging, and yes, BLE module is also connected with UART to the microcontroller. Some
Mm,
BLE module, not I'm not talking about all the BLE modules support this communication protocol, but this is easy to implement. It works on uh, there are it what are the pins of UART?
TX and RX.
Yes, RX and
TX.
yes. So we will see every communication protocol in detail. Okay,
Yeah.
yeah. So how the RX and TX will be connected with each other UART, no? So that
Yes.
connections is important basically. So RX will be connected on the TX of other microcontroller, okay,
Microcontroller.
and
Yeah.
TX of one microcontroller will be connected to the RX of
Another RX
other.
of another microcontroller.
Yes, so this is very important. So other communication protocol is SPI. So it is high speed communication protocol used for
Mm.
sensor and display interfaces. Got
Yeah.
it? So if you want, so this all depends on your applications. Okay,
Mm.
and your simplicity, time consuming. Suppose you don't there are two Bluetooth modules. One is working on SPA, another is working on UART. So which one you will select?
Mm.
Because UART
Uh,
is very easy to implement, so I will select,
implement. Yeah.
I will go with the UART only, na?
Yeah.
But if the project is demanding the BLE
High
should
speed
be high
communication.
speed, yes, high speed communication, then we will go with a SPI.
Yeah, and also for the full duplex mode, we have to choose, I think, I2Z, I think so,
We
because SPI is half duplex.
hmm. And I2C, I think is it's also half duplex.
I think,
SPI, not SPI. I2C, I'm talking about.
yeah, yeah, okay.
Yes, so we will see that what is half duplex, what is a full duplex. Okay, so I will give you the
Yeah.
overview of half and full duplex. So, but basically, what is the meaning of half duplex? So, you are sending data from one side to another, okay, and other side will not send data, okay.
Yeah, that there will be no acknowledgement actually. Yeah,
Yes, yes, and if we talk about full duplex, then you are sending and receiving data at the same time.
same time. Yeah,
Hmm? So this is the
yeah, yes.
yeah. So I2C also works on the two wires. Okay. So basically, this is used for the double EEPROM and ITC sensors
Mm.
interfacing with microcontrollers. Okay. Understood, na? UART
Yeah,
is
yes.
UART is for debugging purpose, and SPI used for high speed communication sensor and display interfacings. Basically, there are some display which communicate with SPI on the basis of SPI with microcontroller. Okay. So when we talk about the internal sensors of microcontrollers, they work on I2C. Okay.
Internal sensors.
Yes, RTC is inside the microcontroller, na? Or double
Yeah,
EEPROM, ROM, ADC, DAC, all work in ADC,
I2C.
ADC, and DAC all support this communication protocol. Understood?
Yes, sir.
So you should remember the purpose of UART. What is the purpose of SPI? What is the purpose of I2C? Okay,
Yes,
you
sir.
cannot use I2C on the place of SPI or SPI on the place of UART. Understood, na?
Mm. Yes, sir.
And CAN is very important communication protocol.
Yeah.
Yeah, so it is used in automotive domain, highly used in automotive domain. Okay, all
Mm.
the ECUs, the whole electrical vehicle ECUs will communicate on the CAN communication. It is used in EV charging system and battery management system. Got it?
Yes, sir.
And another is industrial communication protocol, that is the Modbus.
That's Modbus.
Yes, it is very, very important. It is also very
Yeah.
important. So generally, these three communication protocols are important: UART and Modbus and CAN.
I can.
Okay. So, and this is also important, but I take priority UART, CAN, and Modbus. Understood? So when you want to
Yes,
join any EV charging company, all these three communication protocols you should know: UART, CAN, and Modbus.
yes, sir.
Okay. So
Yeah.
CAN is used for controlling the rectifier inside the charging system. Hmm.
Yeah.
And Modbus is used for taking data from AC energy meters. Okay. It will understand the AC energy meter data, like what is the input voltage, what is input current, है ना, to 230 volt, what is the input power. So it will understand, it will send that data to the microcontroller. Got it?
Mm. Got
And
it, sir.
and UART, basically there are some peripherals which are connected on the UART, like display. There are some displays which also works on the UART communication protocols, BLE
Mm.
modules, and even ESP32 is also work on UART.
Mm.
So two microcontrollers can communicate with each other on UART. Okay.
Mm.
So this is this what I'm telling you is totally depend on the industrial base. It is highly used in industry.
Mm.
Another is ADC. So ADC, you understand, na? ADC, there are a different type of ADCs, 8 bit, 12 bits. Okay.
Yeah.
So basically, the purpose of ADC is to convert analog to digital signals. so that microcontroller could understand, because microcontroller doesn't support analog signals. It understands the digital signals only. No? What are the
Yeah.
digital signals? Basically, the binaries numbers, no? 1010. Hmm? Yes. So you want to sense voltage, you want to sense temperature, you want to sense current. So ADC will be used. And we have gone through the pulse modulations, PWM signals. What is a pulse with modulation? So it is control the power delivery, and application
Yeah.
is motor speed control and fan control. Interrupt controllers are also part of microcontrollers. Understood?
Yes, sir.
So what is the purpose of interrupt controllers? So basically, interrupt controllers handles the urgent events immediately. Suppose you are pressing the button, okay, and suppose can message has been received, timer overflow has been occurred. So interrupt controller will handle those events. And other is watchdog timer. So this question was asked in NXT interview.
Okay.
Okay. Generally, people don't focus on this. What is the purpose of watchdog timer? So it reset controllers if software hangs. Okay, and improve this system reliability.
System reliability.
So this part is very important. Okay, so you can directly tell in the interview, if interviewer will ask you what is a watchdog timer, what is the purpose of watchdog timer, you can directly tell him it resets the controller if a software hangs. Hmm? It is for the
Yes.
safety purpose of microcontroller. So now we will discuss about the architecture of microcontrollers. So there are basically what micro. There are two kinds of architectures. One is Harvard architectures, another is von Neumann architectures. So in my embedded side, on microcontroller side, which architecture we support?
Harvard architecture.
Yes. So what is the purpose? Like what is a Harvard architectures?
Actually, Harvard architecture, they are so structured, and
Mm-hmm.
I think they have separate memory for
Program
program and
data.
things.
Okay, and
Yeah.
so this is because the execution of gets fast. Okay,
Yeah.
and how this program and data memory will be connected with the CPU. There are two kinds of buses, na? There are address, one is
Address
address
bus
bus and another is data
and
bus.
database.
So we will discuss about what is the buses of the microcontrollers in detail as we will move. We will take some other classes as well. Okay, and another is von Neumann architecture. So which in embedded system we don't use von Neumann architectures because it is a single memory for code and data. Okay,
Yeah.
and it is a slower as compared to the Harvard architectures.
Harvard. Yeah.
Yes. So this is also a very important question asked in the interview as well. Got it?
Yes, sir.
So this diagram is very important, okay, that you will get in data sheet of STM32 and official websites. Got it? So basically,
Yes.
system bus, AHP bus is called system bus. Okay, how the peripherals, data memory, code memories are connected with the system bus. System bus is also called as a high speed bus. Okay, you understand the buses?
Yes, sir.
So we will see this, na, this diagram. Okay, so here you are understanding this is your processor. Hmm?
Mm.
Processor is connected with EHP bus. Processor is connected with EHP bus matrix, na? Okay,
Mm.
and how instruction bus, data bus. And S, what is S bus?
S bus
System bus.
systems.
Okay. So with the help of all these three buses, the processor is communicating with AHP bus. Okay. So AHP bus matrix is dividing into basically is connected in AHP bun bus. Okay. Hmm?
Yes, sir.
So AHP bun bus, the speed of AHP bun bus is 120 megahertz frequency. It is high, na? It is very high frequency. Okay. So what are the ports uh, which are connected on the AHP bun bus? GPIO. Hmm? Are you understanding or not?
Yes, sir.
But where is the problem? You are not understanding, I think.
Uh, Actually, what you said now, I couldn't understand, sir.
You couldn't understand?
Yeah, actually, you were asking something, but I couldn't get it.
See, every peripheral inside the microcontroller are connected with each other with the help of buses. Understood? This
Yeah,
this line you understood. So
yeah,
if you will, are you able to see my finger hand basically?
yeah,
Okay, so this part
yeah.
AHB bus matrix. So this is your processor, na? ARM Cortex M3 120 megahertz frequency art oscillator. This is, are
Hmm.
you able to see? This is your microcontroller processor, which is
Hmm.
communicating with AHP bun bus. Okay,
Hmm.
and this AHP bun bus is communicating with RAM, ROM, flash memory, and external memory controllers. Okay, so basically your microcontroller is communicating with these peripherals with the help of AHP bus matrix.
Hmm.
This thing you understood.
Yes, sir.
So AHB bun bus is getting divided into two parts: AHP B bun bus, AHB B2 bus.
B2 bus.
So
Yeah.
what are the peripherals are connected on AHB B2 bus? Camera interface.
RNG camera interface.
Yes, yes. So these are the peripherals which are communicating with processor with the help of AHB2 bus.
Hmm.
And the frequency of AHB2 bus is 120 megahertz frequency. Okay.
Hmm.
And how other peripherals are communicating with processors, like suppose we are talking about GPIOs. Okay. GPIO port A. Are you able to see the GPIO port A? Port
Yeah.
B?
Yes.
Port C? All these ports, all the GPIO ports are connected with processor on the help of by the help of AHP bun bus. This understood?
Yes, sir.
Because see this port is sending some data, so this data will send to the data कहाँ पे जाएगा where data will send AHP one bus.
AHP
So
B1 bus.
AHP B1 bus. So from AHP B1 bus the data will go to the AHP bus matrix. Okay, and from
Hmm.
the AHP bus matrix the data will go to the processor.
Hmm.
This thing you understood?
Yes, sir.
So further AHB bun bus is dividing into the two parts APB2 APB bun bus. Okay,
Hmm.
so definitely the frequency will also be reduced. So if we talk about APB, here you are able to see na APB2 bus. So what are the peripherals are connected on the APB2 bus? What are the peripherals connected?
Uh, EXT, STIO.
These are the timers basically. There are some
Yeah,
peripherals.
timers. Yeah.
UART,
Yeah.
SPI bun.
USART,
SPI
SPI.
bun is connected to the APB2 bus. Okay. and ADC1, ADC2, ADC3 are connected APB2 bus, and the frequency of APB2 bus is 60 megahertz. Okay,
Mm.
now we will talk about APB1 bus. So these are the peripherals are connected with.
Timers and USART and UART.
Yeah. So CAN is connected on which bus?
APB1.
Yes. So
Yeah.
and where timer 3 is connected?
Timer 3 is connected to the APB1.
APB1. So basically, uh, you are suppose this is the CAN protocol. This is the CAN peripherals. This will send some data here. This data will go here and will go to the APB1 bus. And from
Mm.
APB1 bus, the data will go APB AHB1 bus. Okay,
AHB. Yeah.
and from AHB1 bus, the data will go to the AHB bus matrix
Browse.
and will go
Bus
to the
matrix.
processor. Understood?
Processor. Yeah.
This
Yeah, yes,
thing
sir.
understood, this flow understood?
Yes,
Okay,
sir.
so this is the normal flow. So this
Yeah.
is very understandable, like, okay.
Yeah.
So here you are able to see na system bus, AHP bus.
Yeah.
So AHP bus, what are the peripherals are connected to the AHP bus? So AHP bus is also called as system bus. It is 32-bit address channel,
Channel.
32-bit data channel. Okay. So basically 32-bit is the size of the buses. 6, 8-bit, 12-bit, 32-bit, these are the size of.
Mm.
Okay. Data memory, code memories are connected to the AHB buses. So other, I think everything is done now.
Yeah.
So here the complete class is over today's.
Yes.
Okay. Any doubt?
No, sir.
No doubts. Understood well.
Yeah. Understood, sir.
Okay, so I'm sending this PPT to you. Okay, you will go
Yeah.
through this and you will. Okay,
Yeah.
bye.
Yeah, bye, sir.